Do you need something in between? That's the optimal investment for you, and that's what we try to do with the data that we get. Because the worse your power factor or the power factor of your plant, the more you're going to pay in electricity costs. Hi, I'm Eric Solo from Alpha Power Solutions, and today I want to share some knowledge about power factor correction and power factor. What is power factor? Well, it's a measure that we use in the electrical field to determine how effectively power drawn from the grid is actually used on a particular site of a factory, a commercial building. A site that has a poor power factor means that the site is not using the electricity it draws from the grid effectively. This has implications on the electricity cost that the client or the site incurs, because the worse your power factor or the power factor of your plant, the more you're going to pay in electricity costs. That's why it's important. A poor power factor gets addressed. Businesses that have a bad power factor usually have lots of electrical motors, maybe, or sometimes lots of small motors, or a few large motors, but typically an industry that needs lots of electrical motors to be able to produce whatever it's producing will have a poor power factor. You have the grid that is supplying you electricity, and you as a factory or a commercial building, even residential locations, you basically draw two types of power from the grid. One is active power. That's the useful portion of the power that you consume. Say, for example, a motor that drives a pump. The active power that pump motor draws is the power that is converted into mechanical energy to drive the pump, which in turn moves X amount of fluid from point A to point B in a certain time period. So that's the useful portion. That same motor also draws reactive power. And the reactive power is the power it needs to create the magnetic field that it needs to be able to operate. Without a magnetic field, nothing's going to happen. So it's basically the internal usage of the motor. So the grid basically has to supply the active power, the useful portion, and the reactive power, which is required for the magnetic field of the motor. The pump motor actually draws much more power from the grid than what it actually converts into mechanical energy, simply because of that reactive power component. So the grid supplies the active power, the reactive power, but you don't need the grid to manufacture or generate reactive power. You can do that yourself on site with power factor correction equipment. And basically, in its simplest form, it means that when you install power factor correction equipment, you install a generator that can only make reactive power. So if the grid no longer has to supply the reactive power that you consume, then the total amount of power drawn from the grid reduces significantly. And as a result, your electricity costs come down. The analogy of active power and reactive power can be also, compared with a vehicle, a car. The purpose of a car is to move from point A to point B. But when you reach a traffic light, your car is still consuming, you're not moving, but your car is consuming fuel to keep the water pump going, to the fuel pump, all the things that the motor needs to do to be able to operate. That, whether you move or not, it needs that fuel. So now the light turns green, you start moving. Now you're consuming much more fuel because you still have to burn fuel to keep the water pump going and the fuel pump. But now on top of it, your car is moving. So the analogy would then be is that the fuel that your car consumes to physically move you along and move you from point A to point B, that is the active power. And the fuel that you burn at the traffic light and that you continue burning while you're moving to make sure that the water pump and the fuel pump keep running, that is the reactive power, the analogy of a reactive power. You don't really want to spend that money or consume that fuel, but without it, nothing's going to happen. Your car will not move. If there's no water pump, no fuel pump, this car will not do anything. The motor won't turn over. So it's an a necessary evil. It's the internal power usage of, of the motor. So the first step in an investigation into power factor correction requirements of a client always starts with getting data on the amount of power and the composition of the power consumed by a site. Without data, you cannot offer the right solution. You can guess, but it's wrong. If there is an opportunity for you to actually get the data, you should always use it. And sometimes it's not possible. For example, if a customer comes to us and wants power factor correction equipment for a site that is still in the design phase, obviously there's nothing that we can measure, but we can then make educated guesses as what the needs will be. But in a site where the equipment or the production is taking place, data is king, because with the data you can really design the right solution, you can guarantee the savings. It makes so much sense to actually get the data and design something based on that data. So there's two possibilities. Either the client has got online metering, so it's electricity meters that transfer their data onto an online platform, and we get granted access to that data, and yeah, based on that we can do the right design. If that information is not available, we will go to site and install what we call a data logger. It's basically a recorder, a high-speed recorder that measures the power profile of the client, typically for a period of 1 week. And based on that data, we can then design the right solution. So once we have the data, step two obviously is figuring out what the client really needs. We usually add a discussion with the client so we can try to figure out what the future looks like in terms of the client adding equipment, removing equipment, replacing equipment. So in the next 2 to 5 years, what are the intentions of the client? And then we try to quantify what the result in power usage will be. Yeah, so then we identify the optimal solution. And for us, the optimal solution is where the client invests optimally in terms of finding that sweet spot for the client where he spends the least amount of money for the biggest return. Because in this industry, it is possible to go to perfection, but perfection is very expensive. It usually doesn't make sense to try to be perfect in this application because it becomes unaffordable. I like to do the analogy as well because you have lots of options. The analogy I like to use with my clients is, say you need a car for your kid to go to university and back. So a little runaround, cheap second-hand car will do the work. The kid will get home and back. No issue with that. The purpose was to move the kid from home to uni and back. So the little runaround will work. But if you have the means and you really want to offer the child a Ferrari, that is also possible. It will do the same job, but it's still doing the same task, but for much more money. And there are situations where you need a Ferrari, and that's where the design comes into play. But we want to figure out: do you need a Ferrari? Do you need a little runaround, or do you want some that you do not want? Do you need something in between? That's the optimal investment for you. And that's what we try to do with the data that we get. We say, right, this is what we recommend because that is the least amount of money for the most return. Then step three, we make the equipment, and then step four, obviously, we install the equipment. When will the client see the savings? Well, it's literally the month after the installation of the power factor correction solution. Within 60 days maximum will you start seeing the savings. And the beauty of our technology is that if you have the right data, it's absolutely possible to guarantee the savings. There is no, it's black and white. There is really no gray. The only condition we tell our customers if they insist on a guarantee is that you cannot reduce production level. You've bought this from us because this is what you are operating at right now. If you then suddenly have to mothball half of your machines because the orders are not coming in, whatever, you still bought this solution, but you've actually stopped half of your machines. Your savings will be half too, but that is nothing we can do about. These are operational issues, that the client might have. On the other hand, if the client increases or adds more machines, then he will get the promised savings and more. So increasing is never an issue, but decreasing production would have an impact on the return on investment. There is so many possibilities in terms of solutions available to the clients. But coming back to the analogy with the Porsche or the Ferrari and the little runaround, is that a lot of the high end equipment is usually not necessary. It's a lot of additional capital outlay. The operating costs are much higher. But like I said, for specific applications, there is an absolute need to go to the top end of the technology available. But I would say that's maybe 5% of our clients. The rest sit somewhere in between the Ferrari and the little runaround.